WAVE is excited to introduce commercial LED luminaires. We have both styles, the Acorn and the Lantern. And these are the most popular styles that are sold. Let's look at the construction of the WAVE fixtures. On the Acorn, we have a polycarbonate or acrylic globe, cast aluminum fitter. On the Lantern, we have a cast aluminum housing and acrylic lenses. But let's look at the competition. These are all the major competitors that you see out there. We have polycarbonate or acrylic globes, cast aluminum fitters. Both of us have stainless steel hardware. With the Lanterns, again, these are the popular companies. As we compare the two side by side, you can see that the construction is almost identical. The Lanterns do have all cast aluminum housings, polycarbonate or acrylic lenses. So we're equal to the competition on the construction. Now we do have competition from the LED retrofits. And we're going to talk more about the LED retrofits in just a minute. Promoting commercial LED luminaires is different than residential. Showrooms sell design appliances that produce light. Customers don't walk in a showroom and look at a chandelier and ask, how many foot candles will be on my table? Commercial outdoor lighting must complement the exterior design, and it has standards of functionality. Function is measured by photometry. Photometry is the science of the measurement of light in terms of its perceived brightness to the human eye. Lighting levels are measured in foot candles and lux. Not so much lux, lux is more European. But 1.1 foot candle equals 1 lux, 1 foot candle equals 10 lux. Photometric software produces point-by-point foot candles on architectural drawings. Photometric isolines show distribution of the light and the foot candle's distance from the post. What is a foot candle? This is not the foot candle we're talking about. This is a foot candle. A foot candle is the amount of light a candle gives off 1 foot square, 1 foot from the candle. Why photometrics? Safety, lawsuits. Photometrics are important. Architects and engineers demand them. Understanding photometrics make the sale easier. Your knowledge of photometrics is paramount to success. The Illuminating Engineering Society, IES, sets the recommendations for all indoor and outdoor lighting. Most projects must meet their requirements. Additional codes by state, county, and cities may exceed IES recommendations. Architects, engineers, and cities may require photometric report. Sometimes simple isolines and luminaire test results work. Sometimes a point-by-point layout showing the foot candles is required. The IES has standard distributions which are changing a little bit because of LED. For outdoor lighting, we start off with the Type 1, which you can see side by side, goes farther out than from back to front. This is typically used for street lighting. Type 2, you bring it in a little bit, a little more forward light, a little less side by side lighting. Again, it's mainly used for street lighting. Type 3, you basically have equal side to side lighting and front to back. Type 4 pushes most of the light forward, while type 5 comes in round and square and goes in a 360-degree pattern. The most popular are type 3 and type 5. The IES recommendations. We start with the basic. And when I say basic parking lot, we're talking about a very small apartment parking lot, and the recommendation is 0.2 foot candles minimum and a 20-to-1 max to min. Most of your parking lots are going to be minimum of 0.5 with a max to min of 15-to-1. So minimums are really going to range between 0.5 and 1 foot candle. Max to mins must be as low as possible. The more even the light is, the less the eye pupil must adjust. With HID lighting, you get a tremendous amount of light going straight down below the pole. So your pupil closes. As you walk away from that post and the light gets dimmer, it now must adjust and go up. If you have even lighting, like this room is right now, you can maneuver very easily because the pupil basically stays at one position. So low max to min, even lighting is superior to high max to mins. To do a point by point, the following must be known. Got to know the pole height, the light source you're going to use, the luminaire locations. Or we can design a layout. But again, we need to know what's the post height, what's the light source, luminaire minimum foot candles required, any codes concerning the post height, lumen maximum, light trespass, etc. We need all this information. And point-by-point photometric software uses AutoCAD, DWG, or DFX drawings. All jobs are done using AutoCAD, and they all can generate the DWG or DFX drawing and email it to you, and you can email it to us. We can do it and have done it off of PDF. The problem with the PDF is when we scale it up, the dimensions are going to be off a little bit, but we can do it. To do isolines, the following must be known. Again, what's the pole height? What's the light source? What's the luminaire you're going to use? Or we can do several different isolines doing different post heights, lamp source on there, and once we generate it, it'll tell you how far the next post needs to be to have even lighting. But the real question is, how does the Wave LED commercial truly perform? Well, let's take a look at some isolines and point-by-points. This is our Type 5 40-watt LED unit, and you can see we're going out 30 feet away from the post to 0.25 foot candles. So that means to get that half minimum we talked about, the next post needs to be 60 feet away. Well, that's a great distance. Call that 6-to-1, mounting height to spacing. Typical parking lots, 4x4, good fixtures, 5x5. We're going all the way out 6x6. That is great spacing. Now, the pole height in this case is 10 foot, but the light source is up 1.5 feet. So when we run the photometrics, the light source is running 11 feet 6 inches. You can't believe the number of jobs that are done at the wrong height because they're not taking into account where the light source is from the top of the post. And now as we jump to our 60-watt LED unit, we're going out 38 feet 6 inches, so the next post for half-foot candle, 75 feet away. Again, that's a tremendous difference, and that can lower the cost of the job by using less poles and fixtures. That's all well and good, but everybody wants to know, how do you stack up against HID? Well, our 40-watt unit produces 4,300 lumens. 150 watt metal halide, 13,000. Kelvin temperature, we're at 4,000. Metal halide, 4,200. Watts, we're only at 44, while the 150 watt metal halide is at 175. On the 60 watt LED unit, we're at 6,100 lumens. The 250 watt metal halide, 21,000. Kelvin temperature the same, 4,000 to 4,200. Watts, only 58 against 275. But how can 1/3 of the lumens equal the same light on the ground? This is how a metal halide lamp works. It basically throws the light out 360 degrees, vertically and horizontally. All that light going up, which is approximately 40%, goes up to the sky. You don't need it. Now, oh, you also, by the way, have a point source. That little bubble in the lamp is called a point source. It's going to become important later. Don't forget that point. On our LED, all the light's going down. That's why we can use less lumens and get the same amount of light on the ground. And there's your comparison between the two. But the real proof is running isoline photometrics and comparing. On the right, I have a major competitor with 150 watt luminaire Acorn. On the left is our 40 watt LED unit. They're both at 10-foot height. When I do an overlay, you can see they're virtually identical. Now this is our type 3 distribution. It's not a good type 3. It doesn't go out far enough away. It's fantastic distance side to side. We're getting 62 feet, which means the next post for that half-foot candle needs to be 60 foot away. It's closer to a type 2, but it is a great item to use when you have a driveway. You got a multifamily, you're driving in. They're narrow, sometimes 20 feet. That's great optics for that. You're not getting a lot of light trespass. But you got to compete against other people out there. So how do we compete against the best of the best in the marketplace? Great question. I'm glad you asked it. So this is a major competitor, major, well-known, very respected company. This is their approximately 40 watt LED unit. I do an overlay of our unit and you can see quickly that on the 1-foot candle isoline, which is on the inside, we're a little bit better. On the half-foot candle, we're almost identical. On the 1/4-foot candle, they exceed us a little bit. Took it one step farther. Another national competitor. This is their type 3, approximately 40 watt LED unit. Do our overlay. Again, on the 1-foot candle, we're a little better. Half-foot candle, we're better. And the 0.25-foot candle, we're better. But you put any one of those three on a plan, and they're virtually going to come out identical. They're that close. When you look at it on a one-on-one is where you see the difference. When we have multiples, you get all the other contributing light, and they're virtually going to be the same. Here did a little street lighting. It's 40 feet across. Ran 6 units. This is with a metal halide unit. We're getting an average of 1.3-foot candles, max 5.2, minimum 0.4. Ran our 40 watt unit. We're getting an average of 0.9, max of 2.0, and a minimum of 0.3. But let's stack them up next to each other. The wave unit, 0.9 as I mentioned. The metal halide, 1.3. Your eye can't really tell the difference between the two. On the max, we're at 2.0, they're at 5.2. Remember we talked about that max to min? We're 2.5 times better. The minimums, 0.3, 0.4, you can't tell. The eye can't see that. Max to min, because of the max, we're at 6.7. they're at 13. We're almost twice as good, better than the metal halide unit, because the metal halide dumps the light straight down. We're using 1/4 of the energy and better lighting. The LED retrofits, very popular. A lot of you have sold thousands of them, have made nice money on them. How do they work? They shoot the light straight out. The only difference between them and a metal halide is there's very little light going above 90 degrees. But where do we want the light? We want the light going down. Light should go down so we get the good foot candles. That's what people see. They don't walk up at 10, 12 feet in the air. The Wave Secret, there's our module. Again, all the light is going down. Now, we use superior optic control, ultra-high output LEDs, and we have quite a large heat sink to mitigate the heat out of the unit. Our standard is 4,000 K. We do offer 3,000 and 5,000 options. 5-year warranty, multi-volt driver, 100 to 277. This is what it looks like when you light the unit. Now, we are getting a little light going above 90 degrees. That's a reflection from the globe. Light reflects, and that's where it's coming from. There have been manufacturers that say, oh, I got an Acorn, no light goes above 90 degrees. It's impossible, because you're always going to get some reflection going up. But you can see here we're getting very little. All the light's going down, and you can see the angle. Knowing how to read photometric isolines, point by points, and graphs are important. This is our brand new specification sheets for our commercial LED products. And on the back, we have some photometrics. So first one on the top is going to be our what's called polar candela curve. And what this is telling us is what's the intensity of light and the angle it's coming out at. To make it easier, I dropped in some degrees. So you can see at the 30 degree, we have very little coming out. It's closer to the luminaire. We don't need as much light as between the 60 and 75 degree, where we're going farther from the post and we need more intensity. That's how we can get those large distances. And in this particular case, it is tested within the Acorn, so we are getting a little light coming above. And what we're getting downward on this unit is 93.7% of the light. 97.3, going in the direction that we want it. And then we have an isoline on there. Again, this is plan view, so you're looking down on the fixture. This happens to be obviously our type 5, because you can see it's square. Now, the important thing on this one to understand is there's what's called house side and street side. In a type 5, it's not important. In this case, we're getting out 48.9% of the light on the street side, 48.4% on the house side, virtually identical. But if we had the type 3, there would be a difference. If you get a call and they go, all the lights going in the apartment buildings, no light on the street, guess what? The installer installed it backwards. He didn't put the light going out street side. And then finally, on the type 3, we're combining both an isoline and a polar candela curve. And as you can see on the upper left, what we have there is the type 3 coming out, so you can visualize that there's a fixture there and very little going on the house side. Down below is the isoline. So a lot of the information you need, and you can quickly, if you're going up against another manufacturer, you can look at their curves and look at our curves and see how they compare. Now, there are a lot of competitors in the outdoor market. We've gone through some of these majors. Others include Sun Valley Lighting, Visionaire, HCI, King Luminaire, a company called Neptune, and there's quite a few others out there. Comparing pricing is very difficult. The majors are typically $750 to $1,100, but these companies offer photometrics, design layouts. They're well known to engineers and architects, and they're known for quality products. The B players, pricing comes down a little bit, typically $550 on the low end, upwards to $1,000 on the high end. These companies do offer photometrics, design layouts. They're not quite as well known to the architects and engineers. And then you have the C players. And these companies give you very little information. I've never found one that has photometrics. And they're pricing $350 to $750. So I jumped on the web to see what you find if I Google Acorn LED lighting. This company popped up. They're using a commercial size Acorn, 18 watts. Well, we're all in the lighting business, and we all know 18 watts is not going to produce much light on the ground if the light source is up 11 feet. And you're not going to go anywhere below that with a commercial unit. No photometrics for that unit. Another competitor, very, very low price. No photometrics. Little information. They will sell. The problem I see is they will not perform as the end user wants. Let's go on to another one. On the left, we have another company. I think it's 80 watt unit, quite a few lumens coming out of it. No photometrics. Can't do a photometric report. The one I liked the best was the one on the right. It's called a affordable, decorative, municipal quality street lighting package. Includes the luminaire and the post. The post in this unit is 3 inches. You do not use a 3-inch post on municipal projects. Too many people touching them, shopping carts hitting them, all kinds of things going on. You use a minimum of a 4-inch pole, 0.125. And what also I found interesting is all the globes were all refractor globes. And let's go back to that point source on the metal halide lamp. A refractor globe has prisms on the outside. There's a point within the globe that point source is supposed to be. You go above it, below it, it's going to change the distribution of the light to the point they will be glary. I've seen it. It happens. When you're talking about LED, we have multiple point sources. Refractors were not designed for multiple point sources. So that's the competition on the internet that we see. But again, they will sell. Some communities, places will buy them. Wave commercial LED products compete with the majors and the B players. They are about 90% of the market. Very important to understand that. So where do you sell this product? Well, shopping and strip centers. Perfect. They use a lot of decorative lighting, and they love to bring down the energy costs. Again, 4-inch post. Master plan communities. These are terrific. They have streets, walkways, parks, and they own their own property. They don't have to go to the city to meet minimum codes. They can do what they want, and as you can see in this layout, our fixtures look pretty good. Hotels use them in the front entry, sometimes around pools and the walkways. Small town main streets. We're not talking about Los Angeles, New York, Dallas, Cleveland. We're talking about the towns you see on the interstates that say, stop off next exit, see historic downtown. 4-block areas, 6-block, 10 blocks. They don't have the resources to have a big engineering firm doing their designs, and this is a perfect application for our fixtures. But again, you got to watch that post. 4-inch, 0.125 wall thickness. Very important. So in the last few minutes, we discussed wave commercial LED construction, and we had a quick lighting lesson. We talked about the performance and the photometrics of the wave fixtures, and we talked about the commercial LED pricing. The results: wave commercial LED construction, we're equal to the majors. Wave commercial LED photometrics, equal to the majors. Wave commercial LED pricing, we're more competitive than the majors. You should now have the confidence to promote wave commercial LED. It's an easy sell. Thank you.